So the first thing to observe is that you're looking at the limit as x goes to negative infinity. So it's not just a finite number that you can just plug in c and be done with it. So instead, what we have to do when we have a limit as x goes to either positive or negative infinity, we divide by the highest power in the denominator. And that is to put everybody on the same playing field so that we can then figure out who is going to dominate as we go out towards negative infinity. So in this particular case, the highest power in the denominator is this x squared. So we will divide every single one of these terms by x squared. So I have done that here. I've divided each of the individual 4 terms by x squared, and now I have to simplify. So to simplify the 5 over x squared, there's nothing to simplify there. So we'll keep that, and again, we always have our limit as x goes to negative infinity of 5 over x squared. Now, here we have 3x over x squared. So what we do is we subtract the exponents, and that gives us x to the negative 1. Or another way of thinking about this is you have x over x times x. So 1x will cancel out, and you'll be left with 3 over x, and the x will be in the denominator. The 12 over x squared, again, nothing to reduce there. And then the 5x squared over x squared, those will cross out, and you'll just have minus 5. Now, our next step is we use the fact that when the variable is in the denominator, that means the variable is getting really big. And so you're going to have 5 over a really big number, and that will go to 0. So our third step is we use the fact that if we have the limit as x goes to either positive or negative infinity of a number over x to a power, so the variable is in the denominator, that term will go to 0. So again, variable in the denominator here, this will go to 0. The 3 over x, this will go to 0. The 12 over x squared, that will go to 0. So what we are left with here is we are just left with the limit as x goes to negative infinity. In the numerator, everything was going to 0, so we have 0 over, and then in the denominator, we have 0 minus 5, so just minus 5. So here, when we look, our x's are completely gone, and we'll just be left with 0. Now, it is important to note that sometimes there is an x left over, and when that happens, you'll have to plug in x going to positive or negative infinity to determine that sign. So I just want to do one quick example of that where you do have an x left over. So let's look at a question like the limit as x goes to infinity of 5x squared minus 1 over x to the first power. And then let's put like a plus 2 here. Okay, so if that's the situation, then what you want to do is you want to say, okay, I have the limit as x goes to infinity, so I'll divide by the highest power in the denominator. And again, the whole reason why we're dividing by the highest power is to put everybody on the same playing field. So in this case, the highest power is our x to the first. So we'll take 5x squared over x minus 1 over x over x plus 2 over x. And then we simplify. So to simplify here, you'll notice that in the numerator, this first term, because you have x squared in the numerator over just x, when you simplify that, you'll be left with 5x. Then you have your minus 1 over x over, and then our x over x becomes 1. So we have 1 plus, and then 2 over x does not reduce. Now, after we simplify, our third step is to use the fact that when the variable is in the denominator, it will go to 0 as x goes out to infinity. So this will go to 0, and then the 2 over x will also go to 0. So when the dust settles there, you notice that you have a limit as x goes to infinity of 5x over 1. And that is not just a constant. You have that x there. And so this is an example of where your final step is that you plug in an x going to infinity. And really, you know that the answer is going to be infinity because of the fact that x is in the numerator. So this whole plugging in x going to infinity, this really is just to determine the sign, to determine if it's a positive infinity or if it's a negative infinity. That's really what this step is about. So here, I'm going to kind of do this off to the side. I plug in my infinity. I have 5 times infinity over 1. And that's going to give us a positive over a positive, so we'll get positive infinity as our final evaluation.